This is the video for Unit 6, Lesson 2, Transformations. Our goal is going to be to identify transformations of an exponential function and graphing the exponential function using transformations. So we're going to be using this a times b to the x that we've used before. All right, our b to the x is going to kind of act like our parent function. Our a value we know is our, we've been using as our y-intercept. That might change now that we have h's and k's involved. But the a value does do some stuff similar that we've seen with other transformations. So our form we have is a times b to the x minus h plus k. That should look familiar. We did it with linear, quadratic, cubic, absolute value, cube roots, square roots. So we've kind of seen these in lots of different functions already. So a couple things we're going to see when our a value, or I should say the absolute value, if it's greater than 1, we're going to see that it's going to be a stretch, kind of like we've seen where it increases at a faster rate. When it's between 0 and 1, like a fraction that's less than 1, it's going to be a shrink, right? So it's not going to increase at as fast of a rate. And then when our a value is less than 0 or negative, it's going to reflect. Our h values, again, notice the subtraction's part of the formula. So we always kind of take that opposite because that subtraction's there. Our h value moves things left and right. So when our h value is positive, it's going to move it to the right. So this is when it's positive. When our h value is negative, it's going to move our entire graph or shift it to the left, right? So this is where we're going to have our shifts if it's going to go left or right. And then k value does some stuff similar that we've seen. So when k is greater than 0, it's going to move the graph up. When k is less than 0, it's going to move it down. And this is going to shift it up or down. So nothing too different than what we've seen. It's more of just like we're going to be using our table and what we did in the previous section to help us out. So when we look at this first one, we have f of x equals 2 to the 3 times to the x plus 5. So a couple of things that we kind of can see here. We're going to identify all of our stuff. So we have our, I'm going to identify our a. Actually, I'll do the b first. So our b value, and then now we have our a and our h and our k. Our b value is a 3, so that means it's going to be a growth. Our a value is a 2, so it's going to be a stretch. I don't see anything with that exponent of x, so it's h value 0, so it's no change. And then our k value is positive 5, so it's going to be a shift of 5 units up. When we graph it, we can kind of start with like our baseline graph using a times b to the x, and then we kind of just add stuff on here. So if I was to just leave off my h and my k, I have 2 times 3 to the x. I'm going to leave myself a little space next to the x's and y's and just graph it like usual, or make the table as usual. So I'm right negative 2, negative 1, 0, 1, and 2. We do the same thing as before. So our a values are initial amount. So at 0, it's 2. This tells us our like multiplier essentially. So I know this would be 6 times 3 is 18. Divided by 3, or times a third, is 0.67. And then divided by 3 again would be 0.22. We actually do have a k value of plus 5. So we're going to take since that's our y values is associated with that, we're going to take all of our y values and add 5. So this would be 23, this would be 11, this would be 7, 5.67, 5.22. All right, so now when we graph it, these are all of our values. So we have negative 2 and 5.22. So 1, 2, 3, 4, 5. A little bit higher than 5. Negative 1, 5.67 is a little higher. 0, 7, and then we'll have 111, which is a little off the graph, and then the last one's off the graph. Also notice our K value is tied to our horizontal asymptote. So our K value is 5. Our horizontal asymptote, it's not a coincidence that that's also 5. So you can see it's going to get real close to 5, but it's never going to quite get there. For the second one, it's the same thing. So we're first going to go ahead and identify all of our stuff. So I'm going to do B, my A, my H, my K. My B value is 1/3, so I know it's going to be a decay because it's less than 1. A, I don't see anything in front, so that's a 1. My H, notice that's an x minus 1. So if I take the opposite, my H is actually a 1. And then there's no K here, so that's a 0. So I'm going to use 1 unit right? Because it's a positive 1. And now we're going to go ahead and do the same thing. I'm going to leave myself a little space on the table. You like to keep everything to the left because in case you got to do some changes. And so if we rewrite it, it's actually 1/3 x minus 1. So if I write my values, if I use the same thing as before, at 0 it would be 1. I'm timesing by 1/3 or dividing by 3. That's the same thing. So 1/3 would be 0.33. Divided by 3 would be 1/9, which is 0.11. If I reverse it, that would be a 3 and a 9. So it's like, again, it's like you're multiplying by the same thing each time. We also have some stuff that's going to move left to right. So we said our H is actually a 1. So it's like I'm adding 1 to all of these. So I'm going to go ahead and get a -1, 0, 1, 2, and 3. And then these would be all my coordinate points. So -1, 9, 0, 3, 1, 1, 2.33, 3.11. Right? So now when we go ahead and plot this, you're just plotting these coordinate points. And then you connect it. And then again, our K value tells us our asymptote. So K is 0. So we have a horizontal asymptote at y equals 0. So it's, not a coincidence. And if you look at y equals 0, if I highlight it, it's going to get really close, but never quite get there. If you have any questions, you can feel free to ask in class, sign up for T-Bolt time, or go to the center.